Okay, I'm going to talk about some strategies to or put decimals in order from least to greatest, and for just basically how to compare decimals. And the problem kids usually have with decimals is they look at them like foreign numbers that they've never experienced before. And what kids tend to forget is that decimals are just like money, and they've been using decimals since they're a little kid. If the first time they had a piggy bank and saved a few pennies, they were dealing with decimals. So, to make it easier to understand decimals, you have to just think of them as money. And I'm going to give you some strategies to do that. So, let's look at example number 1 here, where we have 1.58 or 1 and 58 hundredths, 99 hundredths, and 1 and 4 tenths. Well, I just said them the correct mathematical way, but let's just think of them as money, and I'll talk about them in a different way now. 1.58 is like $1.58. 0.99 is like 99 cents. And 1.4 is 1 and 4 tenths. 4 tenths of a dollar is 4 dimes, because 10 dimes make a dollar. So we can give a placeholding 0 to the right of the 4. So 1.4 is really just the same as $1.40. Now it's easy to tell which one is the smallest and which is the biggest. So the smallest decimal here is, or the least amount of money is, 99 cents. The second smallest, or the second biggest, is 1.4. If I were the teacher, I would allow you to write that extra placeholding 0, but some teachers want you to write it exactly the way it's written. So you could write it as 1.4 or 1.40. And then the biggest is 1.58. Let's try another example. This one's a little bit trickier. Now, some kids, when they see lots of decimal places, they think that that makes the number bigger, but that's not necessarily the case. So the first step, always make it look like money. Give it a dollar sign. Why not? 3 and 66 thousandths, I'm going to underline all, I call it the money places to the kids that I teach, is like $3.06, but then you have this extra 6 in the thousandths place. We don't have to worry about that unless we need to, and we'll see what happens. The next decimal, we have 3 and 666. That would be called the 10 thousandths, but we don't have to worry about that. This is like $3.06, but then this has 2 sixes to the right of the 6 pennies. And then the last one is just a plain old $3.66. Now we're going to see something interesting here. Now, what would be the smallest? Well, this is like $3.06, $3.06, $3.66. Well, we know that this is the biggest. So what's the smallest? $3.06 with 1 6 to the right, or $3.06 with 2 6s to the right? Well, the $3.06 with 1 6 to the right would be the smallest. So our smallest decimal is this, 3.066, or 3 and 66 thousandths. So we're done with that. The next smallest is the 3 and 666 ten thousandths. And then the biggest is the $3.66. So what's interesting here is the one with the fewest number of places is actually the biggest decimal. Let's look at number 3. And let's make them all into money. Change our color here. Let's use a yellow. So we have 1.6 to make that into money. Think of it as $1.60. Then we have, I'll underline our money places, then we have a $2.25 with a 1 to the right, $2.32, and $1.85. Okay, so what's the smallest? Well, we could narrow that down to the two decimals that are less than $2 would be the smallest. So we have a choice between $1.60 and $1.85. So 1.6 is the smallest. Cross it out. Next is the $1.85 or 1.85, 1 1/85. Now we're down to the 2.251 and the 2.32. Well, just think of it as money. Don't get scared when you see a lot of decimal places. We have $2.25 versus $2.32. $2.25 is smaller. And 2.32. So the advice I have for students and teachers alike is always refer to money. Let's look at our last example. Oh boy, don't these look weird. Lots of decimal places, lots of ones and zeros and repeated digits. That can really confuse a kid. But just take your time, relax, and think of them as money. Let's make this into money. We have a nice even dollar, a dollar and a penny. Oh wow, we have $10. And this is not a penny, remember. This is the 1/10 means a dime. So let's give it a placeholding 0. That's $10.10. Underline all our money places. And now we have another $10.10, except it has a little 1 after it. Okay, this is a nice easy one. Well, what's the smallest? Well, our even dollar is less than $1 and a penny, even though it has a 1 in the thousands place. So 1.001 is the smallest. 1.01 is next. See that? $1, $1, $1 beats $1 because this extra 1 is in the thousands place. Next, we're comparing $10.10 and $10.10 with an extra 1 in the thousands. Well, the plain old $10.10 is smaller, and the $10.10 with a 1 in the thousands place is 1/1000th bigger, but it is bigger. Now, if you want to compare two decimals, if you ever have to, use your alligator mouths to say which one is greater than or less than, that's very easy also. And I'll just do one quick example to end this video. Say we're doing any two decimals, say 5.0 or 27, comparing that to 5.2699. Okay? A lot of times kids get tricked and they only look at the decimal places and they say, wow, these have decimal places, 4 decimal places, that must be bigger than these. But just relax. Think of them as money. $5.27, $5.26. What's most important are these decimal places. First look at those and always go by your money places. These are insignificant now because $5.27 is more than $5.26, so that's greater. So if you always think about decimals as money, that's going to be your key to understanding.